All right, so good morning. What we're going to be doing today is talking about the unit circle. So when we talk about a unit circle, this is simply a circle with a radius of 1 unit. And the center is at the origin. So again, that origin is at 0, 0. So we're looking at a circle in our coordinate plane that has a radius of 1 unit and the center is at the origin. And if you remember what we did last class when we were talking about our special right triangles, 45, 45, 90, 30, 60, 90, the last 3 triangles I had you fill out all had a hypotenuse of 1. So let's take a look at the first special angle in our unit circle. So let's take a look in quadrant 1 and let's draw my 30-degree triangle as my central angle. So right here is my 30-degree angle. So here's my hypotenuse of 1. So if you remember my relationship of my 30, 60, 90 triangle, when my hypotenuse is 1, the side opposite my 30 degrees is 1/2. The side opposite my 60 degrees was square root 3 over 2. So then what happens when I have this point on the circle, the x-coordinate is the same as the side opposite my 60 degree angle, which is square root 3 over 2. The side opposite my 30 degrees is going to be the same as the y-coordinate, which is 1/2. So, and if you remember when I had you fill out that chart from last class, we said the sine of 30 degrees was 1/2. The cosine of 30 degrees was square root 3 over 2. So at 30 degrees, remember in radians, 30 degrees is equivalent to pi over 6. The tangents, remember we had you take the opposite side divided by the adjacent side by your SOHCAHTOA. So when you filled out your chart, what happened was you found that the tangent of 30 degrees was square root 3 over 3. So what happens is, and this will be true for every point on this particular circle, the x-coordinate is going to be the cosine, the y-coordinate is going to be the sine. So let's take a look at the next special angle I had you fill out the other day. We did 45 degrees. So let me sketch my 45-degree angle. So with 45 degrees, in radians, I know that if I was to convert 45-degree radians, it would be pi over 4. Now, if you remember from the triangles and the chart we filled out last class, with a hypotenuse of 1, the side opposite your 45 degrees was square root 2 over 2. So both your x and y coordinate is going to be square root 2 over 2 and square root 2 over 2. So since this side of my triangle is square root 2 over 2, this side is square root 2 over 2, the opposite and adjacent are the same angle, so therefore the tangent of 45 degrees or the tangent of pi over 4 is 1. So the last triangle I had you draw, or we filled out with a hypotenuse of 1, was your 60 degree. So here's my 60 degree. So with a hypotenuse of 1, the side opposite your 60 degrees was square root 3 over 2. Your side opposite your 30 was 1/2. So then when you take a look at 60 degrees, 60 degrees in radians, if you were to convert, is pi over 3. So then at 60 degrees, remember 60 degrees is going to be the opposite over the adjacent. So again, this point, the x-coordinate is the same as the horizontal side of this triangle, which is 1/2. The y-coordinate is the same as the vertical side, which is square root 3 over 2. And again, when you found your tangent, the opposite over the adjacent, you found your tangent to be square root of 3. So if you take a look at your quadrantal at 0 degrees or 0 radians, remember, the radius of this circle is 1, so the ordered pair of this particular circle is going to be 1, 0. So the tangent, again, if you notice what you've been doing is to find the tangent, the opposite over the adjacent, The tangent has been your y values divided by the x values because you've been doing opposite over adjacent. So to find the tangent at 0 degrees or 0 radians, it's 0 divided by 1 or just 0. So there is quadrant 1 of the unit circle. So now if you take a look up here at 90 degrees, 90 degrees is your pi over 2. So if you take a look at this point on the unit circle, again, the radius is 1, so again, my coordinate's going to be 0, 1. Now tangent is the y divided by x. 1 divided by 0, remember, is undefined. So if you know quadrant 1, you can fill out the rest of the circle by simply doing reflections across your x and your y axis. So for example, if you take this point right here at 60 degrees and you reflect it over into quadrant 2, remember what happens in quadrant 2. Your x coordinates are negative, your y coordinates are positive. So what happens right here is at 60 degrees reference angle, this is going to be negative 1/2 and square root 3 over 2. So going back to our study of reference angles, remember, this is making a 60-degree angle with your x-axis. So if my reference angle is 60 degrees, this angle here has to be 180 minus 60, or 120 degrees. And in radians, that's going to be 2 pi over 3. Tangent value is still going to be the same, except again, you have the y, which is positive, divided by the x, which is negative, so tangent's going to be negative square root 3. And again, with your reference angle of 45 degrees as your next angle, 180 minus 45 is going to give me 135 degrees as my next special angle on the unit circle. And in radians, this is equivalent to 3 pi over 4. So this will be negative square root 2 over 2 and positive square root 2 over 2. And again, tangent, y over x, that's going to be a negative 1. So then finally, looking at a 30-degree reference angle. So if your reference angle is 30 degrees, again, I want to find my theta value. 180 minus 30 gives me 150 degrees. And in radians, this is going to be 5 pi over 6. Again, I'm simply going to take this ordered pair, and I'm going to reflect it over into quadrant 2. So my x-coordinate at the 30-degree reference angle is negative square root 3 over 2. The y-coordinate remains positive. Tangent's going to have to be negative as well. So there is your quadrant 2 of the unit circle. Again, you have a point on the negative side of your x-axis. Again, I know the hypotenuse of this circle is 1. So because I'm on the negative side, this is going to be negative 1, 0. Tangent would still be 0. So at 180 degrees, this is going to be pi. So now I'm going to take these points and I'm going to reflect them into quadrant 3. So right here with a 30-degree reference angle, again, this is my 30-degree reference angle, 180 plus 30 is 210 degrees. And in radians, that's going to be 7 pi over 6. Now remember, in quadrant 3, all of your x-coordinates and all of your y-coordinates are negative. So at your reference angle of 30 degrees, both your x and your y-coordinate are negative in quadrant 3. So this will be negative square root 3 over 2, negative 1/2. So tangent then, a negative divided by a negative, is a positive. So that's going to be positive square root 3 over 3. Again, with a 45-degree reference angle, 180 plus 45 gives me 225 degrees. And in radians, this is going to be 5 pi over 4. Again, remember, at your 45-degree reference angle, because you're in quadrant 3, both the x and the y coordinate are negative. The tangent, again, would have to be positive. And then finally, with your 60-degree reference angle, 180 plus 60 is 240 degrees. And in radians, this is going to be 4 pi over 3. And again, remember both your x and y coordinate are negative. Tangent would have to be positive. So down here on the negative side of your y-axis, you've got this point. Again, you still have a radius of the circle 1. So this is the point 0, negative 1. Remember, this is your 270-degree quadrantal angle. In radians, this is 3 pi over 2. Just like at 90 degrees, when I take negative 1 and divide it by 0, this is undefined. So tangent's undefined not only at 90 degrees, but at 270. So then the last and final quadrant, again, if this is my 60-degree reference angle right in here, 360 minus 60 is going to give me 300 degrees. And in radians, this is going to be 5 pi over 3. Now remember, in quadrant 4, your x coordinates are positive, your y coordinates are negative. So when I take my point that's in quadrant 3 and I reflect it over into quadrant 4, the x coordinate is positive, the y coordinate is negative. And tangent would have to be negative again because it's a negative divided by a positive. Then finally, when I take my 45-degree reference angle, 360 minus 45 is 315 degrees. And in radians, this is going to be 7 pi over 4. Again, your x coordinate is positive, your y coordinate is negative. So tangent would also have to be negative. Then finally, your 30-degree reference angle, 360 minus 30 is 330 degrees. And in radians, 330 degrees is equivalent to 11 pi over 6 if you were to convert. Again, when I take this point in quadrant 3 and I reflect it over into quadrant 4, the x coordinate has to be positive, the y coordinate has to be negative. So this is your entire unit circle. The significance of this, remember, cosine is your x coordinate at each angle, sine is your y coordinate at each angle. So if I ask you, for example, the cosine of 45 degrees, the cosine of 45 degrees has to be the x coordinate, which is the square root of 2 over 2. If I asked you for the sine of 135 degrees, sine, remember, is your y coordinate. So at 135 degrees, the y coordinate is going to be square root of 2 over 2. So the sine of 135 degrees is square root 2 over 2. So the way I always tell my students is this. Start with quadrant 1. Memorize quadrant 1 first. Here's a trick to help you remember the ordered pairs in quadrant 1. Remember, we started with 30. Then we go to 45. Then we go to 60. So what I'm going to do is I'm going to make an ordered pair at each angle. I'm going to make all fractions with a denominator of 2. Starting down here with the y coordinate at 30 degrees, I'm going to start with 1 and just count up 1, 2, 3. Then repeat, start going down 1, 2, 3. Square root the numerators. Square root of 1 is 1. Here's square root 2. Here's square root 3. Square root of 1 is 1. Square root 2. Square root 3. Remember, alphabetical order. X comes before Y. Cosine comes before sine. C comes before S. So if you can label your quadrant 1 angles with those ordered pairs, remember, going into quadrant 2 is just a matter of taking these points and reflecting them into the different quadrants. So what we'll really have to do now is just practice the common unit circle values. So a lot of your homework tonight is going to be managing just studying your unit circles. So I'm going to go ahead and rip this page out. There we go. So find the exact value of each expression. Do not use a calculator. Sine of 30. So looking on your unit circle, you go to 30 degrees. Remember, sine is your y coordinate, so the sine of 30 degrees is 1/2. minus cosine of 45 degrees. So go to 45 degrees on your unit circle. Remember, cosine is the x-coordinate, so the cosine of 45 degrees is square root 2 over 2. So 1 minus square root 2 over 2 would be your answer. So it's managing, you're pulling the values off the unit circle, and you're substituting and performing the operation. So now tangent of 45 degrees. So go to 45 degrees. The tangent I found at 45 degrees is 1. Times. Now go to your unit circle, find 30 degrees. So here's 30 degrees on my unit circle. I want the cosine of 30 degrees, which has to be my x-coordinate. So the cosine of 30 degrees is square root 3 over 2. So 1 times square root 3 over 2 is square root 3 over 2. Now, when it comes to doing your reciprocal functions, remember secant is the reciprocal of the cosine. So the first thing you want to do from your unit circle is find the cosine of pi. So remember, find pi on your unit circle, which is right here. Cosine is your x-coordinate. So the cosine of pi is negative 1. So then what you want to do is you want to take the reciprocal of negative 1. So then the secant of pi is also going to be negative 1, because remember, the reciprocal of 1, it's just itself. So the secant of pi is negative 1 minus. Now we want to find the cosecant of pi over 2. Remember, cosecant is reciprocal of the sine. So I want to find the sine of pi over 2. So on your unit circle, here's pi over 2. Sine is your y-coordinate, which is 1. So the sine of pi over 2 is 1. Well, the cosecant of pi over 2, the reciprocal of 1 is just 1. So it's going to be negative 1 minus 1, which is negative 2, when you take the secant of pi minus the cosecant of pi over 2. So when you take a look at D, remember 3 is being multiplied by the cosecant of pi over 3. So I'm not going to do anything with a 3 right now until I figure out what the cosecant of pi over 3 is. So remember, cosecant of pi over 3, we have to first find the sine of pi over 3. So when I go to pi over 3 on my unit circle, sine is your y-coordinate, which is square root 3 over 2. So then to find the cosecant of pi over 3, I have to take the reciprocal, which is 2 divided by square root 3. Or when I rationalize, that's going to be 2 square root 3 over 3. So then what I'm going to do is I'm going to take my 3, multiply it by 2 square root 3 over 3. Plus cotangent of pi over 4. I first have to find the tangent of pi over 4. So on my unit circle, when I go to pi over 4, the tangent is just 1. So then the cotangent of pi over 4, when I take the reciprocal of 1, that's just 1. So when I multiply, remember 3 is actually a fraction over 1. 3 over 1 times 2 square root 3 over 3, those 3's will cancel. So I'm left with 2 square root 3 plus 1. Remember, cosine are your x-coordinates, sine is your y-coordinates. So when you're looking on the unit circle and you want to find the exact value of all 6 trig functions, so looking at 5 pi over 6. So again, to find the sine of 5 pi over 6, we want to find 5 pi over 6 on the unit circle, and I'm going to find the sine, which remember is the y-coordinate. So the sine of 5 pi over 6 is 1/2. Well, if I know the sine, I know the cosecant by taking the reciprocal. So cosecant of 5 pi over 6 is 2 over 1, or just 2. Cosine. So again, I go to 5 pi over 6 on my unit circle. And again, remember, cosine is your x-coordinate. So the cosine of 5 pi over 6 is negative square root 3 over 2. And again, if I want to find the secant, its reciprocal, I'm just going to flip the fraction, negative 2 over square root 3. Don't forget to leave your negative sign. So that's going to give me, when I rationalize, negative 2 square root 3 over 3. So we already found at 5 pi over 6, the tangent is negative square root 3 over 3. So then the cotangent of 5 pi over 6, I'm going to flip this fraction. And again, when I rationalize, that's going to give me negative 3 square root 3 over 3, or just negative square root 3. So that's how you can find the value of all 6 trig functions using your unit circle. Now, when you look at an angle that's greater than 2 pi, to figure out the equivalent angle on the unit circle, what you want to do is you want to find your coterminal angle between 0 and 2 pi first. That will place you in the correct angle on the unit circle. So to find my coterminal angle between 0 and 2 pi, remember I'm going to take my 13 pi over 4 and subtract 2 pi. Remember when I subtract 2 pi with a common denominator, that's actually 8 pi over 4. So 13 pi over 4 minus 8 pi over 4 is going to give me 5 pi over 4. So what happens is 13 pi over 4 ends up having the terminal side at exactly the same place as 5 pi over 4 down here in quadrant 1. I don't know what just happened there. Down here in quadrant 3. So then you can use the values at 5 pi over 4 to help you figure out the value of the 6 trig functions. So the sine of 13 pi over 4. Remember, sine is your y-coordinate. So at 5 pi over 4, the y-coordinate is negative square root 2 over 2. I'm going to find the cosecant. I'm simply going to take the reciprocal, negative 2 over square root 2. And when I rationalize, that's negative 2 square root 2 over 2, or just negative square root 2. The cosine. The cosine of 13 pi over 4, again, I'm going to go to 5 pi over 4, which is its coterminal angle. Remember, cosine is your x-coordinate, which is negative square root 2 over 2. The secant, well, the secant's going to be the same as the cosecant, which is negative square root 2. Tangent of 13 pi over 4. So go to 5 pi over 4. Remember, tangent's just 1. Then the cotangent of 13 pi over 4 is just going to be the reciprocal of 1, which is 1. So like I said, when you're dealing with angles that may be greater than 2 pi or less than negative 2 pi, find your positive coterminal angles first. So for example, at negative 5 pi, I know negative 5 pi is smaller than negative 2 pi. So I'm going to have to add 2 pi, which is still going to give me negative 3 pi. Add 2 pi again, which is negative pi. I'm still not between 0 and 2 pi, so I'm going to add 2 pi again, which places me at pi. So the coterminal angle for negative 5 pi is pi. So I'm going to look at the values on the unit circle at pi to help me calculate those values on the unit circle. So then when I want to find the sine of negative 5 pi, remember, sine is your y-coordinate. So I'm going to look at pi, which is the coterminal angle for negative 5 pi. The y-coordinate is 0. So when I want to find the cosecant of negative 5 pi, remember, 0 over 1 is actually, when I do the reciprocal, is 1 over 0. That's undefined. Remember, you can never have 0 in the denominator. Remember, 0 is the one number in our number system that does not have a reciprocal. So anytime you have to take the reciprocal of 0, it's undefined. Cosine of negative 5 pi. Go to pi, that's the coterminal angle. The x-coordinate at pi is negative 1. So the cosine of negative 5 pi is negative 1. Secant. Well, the reciprocal of negative 1 is just negative 1. Tangent of negative 5 pi. So go to your pi, which is the coterminal angle. The tangent at pi is 0. So when I want to do the cotangent of negative 5 pi, That's going to be undefined. So that's how you can use your unit circle to help you find the exact value of the 6 trig values. So now there's a lot of other angles, obviously, that are not on the unit circle, and we're going to have to use our calculator. So if you want to grab your calculators. Now what you have to pay attention to is the mode. What mode is the angle given to you? So if you look at 9a, pi/8 is in radians. So make sure you are in radian mode on the calculator to calculate this. So again, remember where mode is. Go to mode. The third option down, you will see radian or degrees. So I'm already in radian mode. So to find the cosine of pi/8, you have 3 of your 6 trig functions on your calculator: sine, cosine, tangent. So I'm just going to select cosine of pi divided by 8. Always round to 3 decimal places, so that's going to be 0.924. Now, these buttons, second sine, I know you see that sine to the negative first, cosine to the negative first. That is not your secant, cosecant, and cotangent. That's a completely different function in itself. So the only way you can do cotangent on the calculator, again, first of all, check your mode. This angle is given in degrees, so make sure your calculator is in degree mode. So again, I'm going to go to mode, change this to degrees. So what you have to do is you have to rewrite cotangent as a reciprocal 1 over tangent. So on your calculators, what you have to do is you have to type in 1 over the tangent of 41 degrees. So again, I changed my mode to degrees. So 1 divided by the tangent of 41, 1.150. Always check what mode, when you're dealing with calculators, always check the mode that your calculator needs to be in. So again, right here, 5 pi over 12. This is radian, so make sure you are in radian mode. So again, cosecant is reciprocal of the sine. So the only way on your calculator you can do the cosecant is you have to rewrite this as 1 over the sine. So to type this in my calculator, it's 1 over the sine of 5 pi over 12. Yeah, I did change. I had to double check to make sure I changed my mode. 1 divided by the sine, and that is 5 pi over 12. So 1.035. So that is your unit circle and some calculator problems for today.